So, good morning. What we're going to do today is to review for the final exam. Yeah. Yesterday I reviewed a little bit with my hybrid class. So let me see what we did yesterday. So this is what we did yesterday. This is SLO 1 and 2. So determine the end behavior, and there are 4 end behaviors. Should I do the same thing again with you guys? Yeah. Okay. So, and then given a rational function, okay, so let's do it again, yes? So, let's see, SLO, so given a polynomial function, this is listed in your syllabus. So, given a polynomial function, determine its end behavior. Alright, yeah. Now, there are 4 end behavior. Do you remember those? So the first one is the one that looks like a parabola. And when do you have this? Y is equal to what? X squared, x to the 4, x to the 6, anything with even exponent. And then this one is, this is a parabola that opens down. Y is equal to negative x squared, negative x to the 4, negative x to the 6, etc. Even exponent. Now, you also have something that looks like x cubed, y equals to x cubed, x to the 5th, x to the 7, etc. And the other one? Yes. Y equals to negative x cubed, or negative x to the 5th, negative x to the 7th. So it's based on your leading coefficient. So if I just give you f of x is negative 3 x to the 4th plus 3x plus 7, which of the end behavior would work and why? Which one? The second one? This one? Yes, why? Yes, leading coefficient negative and even power. Got it? So I think that's 2 points on your SLO. Yeah. Okay, the second one is given a rational function, we graph. Of course, you have to find the asymptotes, those things. Yeah, so let's look at the sample final or the previous sample test. Now, does everything have a sample final? No? Then what are we reviewing? So you are going to access your sample final. Now, do we have it on the website? We do, right? Okay. So tell me which ones we're going to do. Because I'm not going to do it for you. Let me see. So look at your sample final or the previous sample test. This is chapter 3. Yeah. So, or the previous test, either way. But you need to look at your sample final. All right. So I'll wait for you. Everybody should have their sample final. Yeah. Yes. Yes. There's no sample final? Really? Yeah. Okay. What about chapter 3 sample test? What about that? Do you guys have it? Oh, okay. Why don't we open that? So there is a rational function which we want to graph. Yeah. All right. Okay, so Did you find it? So which one should we do? Let me see. So if you have your old test, that would work too. This is chapter 3, right? Maybe something like number 14 or number 15. Which one do you want to do? 14, 15? 14, 15? What? Number 1? No. We're talking about rational function. Yeah. 13, 14, 15. Yes. So it starts from number 13. Maybe number 14? Yeah. So graph f of x is equal to x squared plus x minus 72 divided by x squared minus x minus 56. So this is sample test 3, number 4. Okay. So what would you do here? Well, the first one is vertical asymptote, right? Oh. That's not what you have? What did you have then? Tell me. Oh, no, that's not a rational function, is it? How come we have a different one? Are you serious? It's a different one? Yeah. Oh, okay. So, let me see. Why is it different, huh? CDS. Oh, okay. Chapter 3, Stewart. Okay. So, it starts with number 19, 20, 21, 22. How about number 22? Yeah? So, f of x is equal to x times x plus 4 divided by x minus 5 squared. All right. Yes? Vertical asymptote. So how do we find vertical asymptote? Set the denominator equal to 0? Yes, that's right. So what will be the vertical asymptote? Yes, x is equal to 5. So notice that this is the multiplicity is 2 or the power is 2. Yeah. So we're going to be careful later on. Okay. Now what about the non-vertical asymptote? All right. So how do we get the non-vertical asymptote? It's based on what? There are 4 cases, isn't it? Okay. So which case is this? Case 2. So the degree of P is equal to the degree of Q. So what is your non-vertical asymptote? Y is equal to 1. Yes. The leading coefficient of P divided by the leading coefficient of Q. Yes? So far so good? Okay. So remember there are 3 cases. So you got to review those. Yes. Now what about the x-intercept? So set y is equal to 0. So when y is set y is equal to 0, 0 is equal to x times x plus 4. So x is equal to 0 and x is equal to negative 4. So 0, 0 and negative 4, 0. Yes. Now D, y-intercept. How do we get y-intercept? Set x is equal to 0. So what happens when x is 0? F of x is equal to, f of 0 is equal to 0. All right, yes. Now, this is important, and I always ask, determine, oh, probably it doesn't, because it's an SLO. I follow exactly what the other people are asking. Determine if the function intersects the non-vertical asymptote. Okay, this is important. So how would you answer this question? So what is the equation of the function? Y is equal to x times x plus 4 divided by x minus 5 squared. What is the equation of the non-vertical asymptote? Y equals 1. So how do you find the intersection between these two? Yeah, you set them equal to each other. Yes. X times x plus 4 divided by x minus 5 squared is equal to 1. All right. So we could cross multiply. Yes. So x squared plus 4x divided by, is equal to x minus 5 squared. So x minus 5 squared, what is x minus 5 squared? X squared plus minus 10x plus 25. Yes. All right. Yeah. So did they intersect? So add 10x both sides. So this is 14x. 14x is equal to 25. Okay, then what? Divide both sides by 14. So x is equal to 25 over 14, which is approximately what? 111 over 14. What is it in decimal? 1.8 or 1.7? Okay, would you guys please tell me? 1.78, so that's going to be 1.8, right? All right, good. So what is your answer? Do they intersect? Yes, they intersect at 25 over 14, comma 1. Okay, so now let's graph. So after E, we're good to go. We're graphing. All right. So we're graphing this, right? So what are we graphing? Let's see. We're graphing x equals 5, y equals 1. 3 cases, but this is case 2. 0, 0, and 25 over 14, comma 1. 1.8, comma 1. Yeah. All right. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, and okay. So let's see. X equals 5. So x equals 5 is right here. Yay, okay. And then y equals 1 is right here. All right. So now let's draw the points. 0, 0 is here. And negative 4, 0 is right here. All right. Good. Yeah. Okay. Negative 4, 0, 0, 0. All right, and does it intercept? Yes, at 1.8, comma 1, so it's around here. So this point here is 25 over 14, comma 1. Yeah. So now let's think about, oh, well, let me wait. Yeah. Okay, so let's think about how the graph will look. Any idea? Well, you actually have a pretty good idea, right? So this is the asymptote, so it's going to get closer and closer to the asymptote. And what happens here? It's going to go down, and then it's going to go here, right? Yes or no? Yeah, that's the only possibility, right? Okay, so it looks like this. Now, let's figure out what happens to the right. So, let's see here. Do you think it's going to start up here? Or is it going to start down here? So, or down here. So, is it going to look like this or look like this? Which one and why? Any idea? The top or the bottom? Yes. Which one are we looking at? Now, let's look at these. This is x minus 5 squared. So, odd or even? Even. The power is even. So, if it is even, then they both start at the same place. Yeah. So, if we know that the leftmost from the left, it's up here, then on the right, it's also up here. This is when the power is even. What about if the power is odd? Opposite. Do you still remember that? Okay. Yeah. I think the one on the final, I think the power is probably odd. So yeah. So it's probably one start from up, the other one starts from the bottom. But you have to remember. Yeah? Okay. Now, the other thing that's going to be on the final, I will tell you, it's going to be the proof by induction. Proof by induction. So it's one question. And didn't we do a lot of examples for proof by induction? So base case and induction step, right? Okay, so we don't need it. And also expand binomial. So for example, we're talking about 5x squared plus 3y cubed z, and then raised to the 5th power. This is from 11.5. We did them yesterday too, right? Oh no, on Tuesday. Because yesterday we had a test. So proof by induction, you think you could do it? Yeah. What about the binomial expansion? Yes? Okay, good. That's for sure. And then from the previous stuff, from the previous material, you are going to have finding zeros. So let's see, finding zeros, finding all zeros. Let me see, which one it is. Yeah. Finding all zeros. Let's see, which one. How do we find all zeros here? All right. What about Let me see. Which one is this from your sample? Yeah, here. F of x is equal to x cubed minus x squared minus 8x plus 12. So we want to find all the zeros. So what are we going to do? So I want to find all the zeros, including complex, if it is complex. So what would you do here? Yes, so first of all, we always start with possible rational zeros. All right. Okay. So f of x is p over q, right? What is p over q here? Plus or minus what? 1, 2, 3, 4, 6, 12 on top, divided by 1. Yes. All right, then what? So you stop trying. So does it work for 1? No. What about for 2? Does it work for 2? What is f of 2? So f of 2 is 8 minus 4 minus 16 plus 12. Is it? Oh yeah, it is, right? Yes, equal to 0. Remember that? So 2 is a 0 of f of x. Okay, good. Now, what do you do next if 2 is a 0? What is it? Is synthetic division? All right. So 1, negative 1, negative 8, 12. And then 2. All right. So bring down the 1. 1 times 2, 2, 1. 1 times 2 again, 2 again. So this is negative 6, 12, 0. All right. Then what? So f of x is equal to x minus 2 times what? X squared minus x minus 6. Yay. Okay. Now, is x squared minus x minus 6 factorable? Yeah. If not, then you have to use the quadratic formula. Yeah. So factor this. What is this? X plus 3, x. No. Is this right? No. It's supposed to be what? X plus 2, x minus 3. Yes. So, all zeros. What are all the zeros? 2, negative 2, what else? 3. Yes. Yes. Oh, yes. You're right. So that's why this is supposed to be minus and plus, right? Yes, you are right. So this is supposed to be x minus 2x plus 3? Yes. So what are all my zeros? 2 and so 2, the multiplicity is what? Yes. It's 2. So it touches. Yeah. And negative 3. All right. Good. Do you think we should graph this? So let's graph this. Yeah. So let's graph this function. So let's graph this function. Okay. 1, 2, 3, 4, 5, 6. 1, negative 2, negative 3, negative 4, negative 5. Okay. Alright. So 2, the zeros are 2 and negative 3. Alright. So, what about the end behavior? Does it start up or start down? Start low or high? Start low. So it's going to look like this. So the end behavior, it starts low and end high. So we know it's going to cross here, right? Do you know why it crosses? Why does it cross? Multiplicity, yes. Then what happened at 2? What's the multiplicity, even or odd? Even, so it will what? Touch, yes. So it's going to look like this, and then like that. Finish, yeah. And it doesn't matter, you want to draw it a little bit higher or lower, but just make sure in here, it's no sharp corner. Yeah, when it touches, it is not a sharp corner. Okay? That's it. You're done with the graph. So it's pretty easy. It's using the zeros. Okay? Now, what else is in here? Let me see. Do you remember the oblique asymptotes? How do you find the equation of oblique asymptotes, and when do you have them? Yes. So, oblique asymptote. Do you remember? Case 3, yes. So, you have oblique asymptote exists when the denominator, when the degree of P is equal to degree of Q plus 1. Yeah? So, and how do we find it? So, for example, find the oblique asymptote. So y is equal to x squared minus 8x plus 5 divided by x plus 2. How do we find the oblique asymptote? Yes, you can use long division. Well, actually here, can we use synthetic? Yes, for this one, yes. So let's use synthetic. What will that be? 1, negative 8, 5 divided by negative 2. Yes. So bring down the 1. 1 times negative 2. Negative 2, negative 8 plus negative 2. Negative 10. Negative 10 times negative 2, 20. And then 25. Yes. What is the equation of your oblique asymptote? Y equals x minus 10. Yeah. So this is the equation of the oblique or slant. Oblique or slant is the same. Asymptote. Because we usually have horizontal and vertical, right? So this is slant asymptote. Okay, so those are from chapter 3. Let's look at chapter 4. Do you remember what chapter 4 is? You also have transformation, by the way. This is chapter 2. Should we do one problem of transformation or no? The shift, the string, yes? Okay, so let's open chapter 2. Sample. Oh. All right. Oh, what am I doing? I have something with that. My books. Okay, so what were we gonna do? I'm sorry. Chapter 2, okay. The transformation? Yeah, probably something like number 4 or 5 or 6. So pick one. Which one? Number 4, number 5, or number 6? Which one is that? Which one? Number 6? Okay. All right. So this is like sample test, sample test. Okay. All right. So y is equal to absolute value of 1/3 x. Oh, 1/3 is outside. 1/3 outside x plus 6 minus 2. All right, so what do you think? So A, basic graph. Y is equal to, yes, oh, y equals B. Then what? So you have your basic graph, then you want to state the transformation. All right. So 1/3, what does 1/3 do? What is it? What does this 1/3 do? What compress? No, 1/3 is actually outside. Yeah, so it is always related to y, right? So since 1/3 is outside. So vertical compression, yeah, vertical, by a factor of 1/3. Yes. Good. Now, what does plus 6 do? Oh, the battery is 3 minutes. Yes. What does plus 6 do? Shift what? Where? Shift left 6 units. Okay. And then, what does negative 2 do? Shift down 2 units. Are we okay so far? Yeah. Do you think you can graph it? So choose 3 points and then apply the transformation. So choose 3 points. Apply the transformation step by step. All right. So what points do we choose for absolute value of x? 0, 0. What else? I'm going to choose negative 3, 3, right? You know why? Yes. So negative 3, 3, 0, 0, and then 3, 3. Okay, vertical compression by a factor of 1/3. So what do I do? Multiply y by 1/3. So negative 3, 1. And the x stays the same. So let's just copy the x and the y multiplied by 1/3. Remember this? Okay, next. Multiply by 1/3. What's next? Shift, yes. How do I do that? Yes, subtract x by 6. So the y stays the same. So 1, 0, 1. Okay, what about the x? -9, -6. What is it? -3. Yes. Good. Yeah. And last page, last step. Subtract 2. Y by 2. All right. So x stays the same. -9, -6, -3. And the y we subtract by 2. 1 minus 2 is -1. -2. 1 minus 2 is -1 again. So you think you could graph it? Yeah, doable? So if you have to have a V, right? It's just that the V will be, what is it called, taper down a little bit because you did a vertical compression. So it's not going to be 45 degrees, but I think it will be tapered down, even though the shape has to be a V. Right? Absolute value is a V. Yeah. All right. Now, the next one. Are you okay so far? Yeah. The next one, chapter 4, is logarithmic and exponential equations and applications. So let's see. Let's look at chapter 4 sample. So we have 12 minutes. Which one do you want to go over actually? Well, I don't remember. Do you still remember how to do the Gauss-Jordan elimination? Okay, I think I asked that. So let me write down Gauss-Jordan elimination. Do you remember which one it is? You have to change the matrix to row echelon form, remember? Okay. That's Gauss-Jordan elimination. Yeah. And what is the other one? Let me see. Do you remember Kramer's rule? I don't remember which one I asked, but you have to remember both, right? Kramer's rule is the one in which we have to find the determinant. Yes. Remember that? Okay. What else? 1, 2, 3. Oh, I don't even remember how many problems I put. Let me see. Gauss-Jordan, this one. Exponential and logs. No. Equation or word problem. Exponential and logs. Yeah. So should we go do exponential and logs? Yeah. Okay. So that's chapter 4. Yeah. So open chapter 4 sample test. All right. Do you want to graph or not? No? Oh, okay. Okay, so number 1. So it's transformation also. Yeah. Sample test 11, number 1. So f of x is equal to -2 raised to the x plus 3 plus 4. All right. So tell me, what is the basic function? Sample test for test for okay. What is the basic function? Y equals to 2 to the x, right? Okay. What are the transformations? So transformation, this is an S, isn't it? So transformation. Okay, so what are they? The negative. What does this negative do? Yes, reflect. Yes, about the y-axis. Y or x? No, it's actually x. Yes. Right? So the y changes, one positive, the other one's negative. Now, B, x, what does plus 3 do? Shift right 3 units. Left 3 units, right 3 units. Huh? I'm tricking you guys, right? Okay. And then, what about the 4? Up or down? Yes. Shift up 4 units. All right. Good. Now, pick 3 points from the original function, y equals to 2 to the x. Remember the asymptote. So whenever we have an asymptote, you have to remember. So what are the 3 points? What are the 3 points on y equals to 2 to the x? Yes? Yes, 0. 2 to the 0 is 1. 1. 2 to the first power is 2. And then what? That's it? One more. 2. Okay. If it is 2, then what is y? 4. Yes. 2 squared. 2 to the 0 is 1. 2 to the first power is 2. 2 to the square is 4. How do I reflect about the y-axis? Multiply y by -1. So 0, 1, 2, the x's stay the same, and the y changes. So -1, -2, -4. Right. Now, shift left 3 units. What do you do if you shift left 3 units? Which one, x or y? Yes. So if x minus 3, then we have -3, -2, -1, and then -1, -2, -4. Last one, what do you do? Yeah, add y by, yes. But anyhow, you guys can do it, right? So the x stays the same, -3, -2, -1, and you add y by 4. So 3, 2, 0. And then you graph, yeah? All right. That's it. Good. So this is chapter 4, but there are other chapter 4. And we didn't go over them today. So which one is exponential equation, log equation? Do you remember? Yes, the interest. Yeah. Should we do one problem or what? Which one? The interest? Let me see. Okay. So chapter 4, right? Oh, which one do you want to do? Number 7? Or number, let me see. Number 44? Oh, which one? Number 45? Okay. Number 45. Sample chapter 4. $45, right? You said? Okay. So, if Emery has $2,000 to invest at 12% per year, compounded monthly, how long will it be before he has 3,500? So also, if the compounding is continuous, how long will it be? Round your answer to 3 decimal place. So what is given? Yes, P is 2,000. Yay. Good. Then A is 3,500, is it? All right. What about the interest? Yes. So 12%, R is 0.12. Good. Compounded monthly. So what does it mean? N is equal to 12. Yes. Find. What do we need to find here? The time. Yes. Okay. Then what formula do we use? A is equal to P times 1 plus R over N raised to the NT, yeah? So A is 3,500 is equal to 2,000, 1 plus 0.12 divided by 12. Multiply by 12. All right. What would you do here? Divide both sides by 2,000. Yes. All right. So what do I have on the right? 35 over 2. Is it correct? No. 1 plus 0.1, right? 1.01 raised to the... Is it 1.01 or 1.01? Okay, raised to the 12t. Okay, good. Then what do we do? So 3,500 divided by 2,000. What is 3,500 divided by 2,000? Huh? 1.75? Yeah. So equal to 1.01 raised to 12t. So ln 1.75 both sides, right? So ln 1.75 is equal to 12t times ln 1.01. All right. So how do I solve for t? Divide by 12. What is it? 12 ln 1.01. Yes. All right. Can you give me an approximate of time? What is this time? ln 1.75 divided by 12 times ln 1.01. Yeah. All right. Can you give me an approximate p-value? Yeah. 9 o'clock. Yeah. You can sit down. No, you can sit down. Can you give me an approximate value? What is it? 4.6? 4.7? Oh, so how long does it take? 4.7 years. Yes. All right. Oh, it still takes long, right? From 2000 to 3500. Yeah. Okay. So, is everybody okay so far? Yeah. Okay. So anyway, you guys had a good class. I really like teaching the class. So everybody will take calculus next semester? Spring? We don't offer calculus in the winter, do we? No, so spring. Already registered? Okay, good. Yeah. Okay, so good luck. Your final will be on Thursday, 7 a.m. to 9 a.m. Yeah. Next week, there is no class at all. Yeah. And, yes. No, yeah. I think the best way is even to look at the actual test. The actual test that I gave you and review those first. Plus chapter 11. Remember those two, a few sections which we didn't do? Yeah. So good luck. Yeah. I will see you on Thursday. Yeah. Thursday morning, 7 a.m. Huh? Oh, yeah. Some of you take it at 9:30? Yeah. Okay. Sure. Okay. If you haven't brought me the chapter 11 portfolio, 11.4 and 11.5, or 11.5, 11.6, or what's the 3 sections? 11.3, 11.5, 11.6, right? 3, 4, 5? Okay. Please bring it next during final. Okay? Yeah. All right. See you later.
So the second test will be 9:30?
Yes. Yes. So you'll do the 9:30? Okay. Yeah. 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 Yes. Let me see. Let me turn this off first. You're gonna get some grading? Yeah. I haven't graded it. So, well, this one is not so accurate because it doesn't include the last one. Okay? So let me close this first.